Hello guys, and welcome back to Introduction to Number Theory. In the previous videos, we've seen that finite continued fractions correspond to rational numbers. Here we see a continued fraction, but please don't be mistaken. This is an infinite continued fraction. This line here means that 2 and 5 form a periodic part of the continued fraction. So it can be rewritten as 3, 1, 2, 5, 2, 5, 2, 5, and so on. So it is an infinite continued fraction. And now we will try to calculate the value of this continued fraction. First, let's write it in the standard form. So 3 plus 1 over 1 plus 1 over 2 plus 1 over 5 plus 1 over 2 plus 1 over 5 plus and so on. So it is infinite and we can never write it to the end. And now notice that this part here, beginning from 1 over 2 plus 1 over 5 and so on, is the same. So since it is infinite, it is the same as this part here. Well, what does this mean? If we denote this part as an x, so this will also be equal to x. And we can simply write that x is equal to 1 over 2 plus 1 over 5 plus x. Here we see that this 2 corresponds to this one, and 5 corresponds to 5, and all the rest of the continued fraction corresponds to x. So now we have an equation where x is the unknown variable. And we will try to solve this equation and take a look at the form of x. Now, to solve this equation, we simply transform the right-hand side into a simple fraction. So here we write that it is equal to 1 over 2 times 5 is 10 plus 2x plus 1. It is 11 plus 2x over 5 plus x, which is equal to, finally, it is equal to 5 plus x over 11 plus 2x. So we see that actually this equation is a quadratic equation. Move the denominator to the left-hand side and then write that 2x squared plus 11x is equal to 5 plus x. And finally, 2x squared plus 10x minus 5 is equal to 0. We know that quadratic equations usually have 2 roots. Well, they can have 0 roots or 1 root or 2 roots. Well, we expect that one of the roots of this equation is this continued fraction here we denoted by x. But there is another root, and now we will need to decide which of these roots really corresponds to x. So let us solve the equation. In order to solve this equation, let's write down the discriminant of the equation. Actually, since coefficient with x is even, we'll write 1/4 of the discriminant. Well, it's equal to 5 squared, where 5 is not this one 5, but 10 divided by 2. So 5 squared plus 2 times 5, plus because we have minus here, and 2 multiplied by 5, and it is equal to 25 plus 10, it is 35. So the solutions of this equation are x, the first and the second one, they are equal to minus 5 plus or minus square root of 35 over 2. We need not multiply this coefficient by 2 because here we took 1/4 of the discriminant. Which of these values actually corresponds to our continued fraction? Well, we understand that x over here is greater than 0. And also we understand that one of these values is less than 0, it's negative. And the other one is positive. So we take the positive one and finally conclude that x, this one x over here, is equal to minus 5 plus square root of 35 over 2. Now, in order to find the value of the initial continued fraction, we need to take this value of x, substitute all this by this obtained value, and then roll it all up in order to find the initial continued fraction. We will not do this. What is important to us is that the initial continued fraction will also contain square root of 35, and it will be of the form, let me now it will be of the form some rational number, like here, but some other probably rational number, a plus b, also rational number, multiplied by square root of 35. And 35 is some natural number that occurred when we solved this quadratic equation. So the conclusion is that the meaning of a periodic continued fraction, actually the value of the periodic continued fraction, will always be of the form a plus b square root of n, where a and b are rational and n is a positive integer. Once again, the main conclusion is that the value of periodic continued fraction, where being periodic is essential, crucial to us, the value of the periodic continued fraction is a quadratic irrationality, which means rational plus, well, square root of rational. Or we can say that rational plus rational multiplied by square root of integer.